Welcome to the next tutorial for simulation and prototyping. This tutorial is going to cover kangaroo2, and we're going to do it through a few successive iterations. First, I'd like to show just a simple Catenary 2D example, which will highlight the concepts and all of the different components or things that we're going to need to create the simulation. And then we'll look at more complex examples. So for this tutorial, you're going to need to download and install kangaroo2. Kangaroo2 is a physics simulation, and it allows us to apply a force, and it works with a mesh. We'll talk about what that means, and a kind of spring model. And so I'll demonstrate what that means, how it plays out, but we'll use this for form finding. And so we've talked about examples of like Gaudi's hanging chain model. We've talked about Musumeci's bridge. And in these examples, what we saw was an idea about being able to explore material properties as a way, or physical properties as a way to explore form. And so kangaroo2 is a really great computer simulation tool that allows us to do that. We've been talking about simulations in class and exploring that topic through readings. And as we know, there are different aspects to that, and there's a whole philosophy tied into this as a methodology. And so now is your chance to begin to use some of these things and kind of play with them. And I think that's really what they're made for at the design stage. So what we're going to do in this tutorial is I have a really simple courtyard example here, and we're going to create some tensile roof coverings for this. And we're going to use a couple of different approaches. And as we work through those different approaches, you'll start to see what's consistent and what varies between them. And so this is an example here that we will build. I'll show you a second example. Each of these uses a different, some different minor approaches within Grasshopper. And then the one that we'll start with is here, which is just a surface that's draped. And so this will be a great way to understand how the simulation is working and what it does. So with that, why don't we get started? And before we begin modeling with this specific example, and so let's see, I'm going to unhide all of my geometry that's here and delete it except for the existing geometry. The first thing that we're going to do is we're going to work in the front view and away from the model, just because I want to work abstractly to start. So why don't we start with a new Grasshopper definition. And let's start with just one line. It doesn't matter how long that line is, but just draw in the front view a horizontal line. As a way to capture this, we will create a curve container, and we'll set our curve to that curve container. We can then hide our curve. So let's do a couple of things. So within kangaroo2, so once you have it installed, you should see a tab up on the top called kangaroo2. And there's a main component. There are a number of different solvers that we have here. For everything that we do today, we're going to use the Bouncy Solver, just because it is a little more interactive in terms of the way that it looks. There's so much to learn with kangaroo2. I'm just going to scratch the surface today and expose you to some of the things to get you started with this. So select the Bouncy Solver. And while you're here, select the show component. And what we're going to do is we're going to build, before we do anything, we're going to build a really simple set of tools here that we'll use throughout this tutorial. So the first thing that we want to do is to create a merge component. And because we're going to have a number of items that come in to the goal objects. And so as we add these, they'll be merged and then they'll be brought into the solver here. We want to have a button. And this button we will use for resetting the geometry. And this will come in handy. We want to create a Boolean toggle. And we'll use this to turn on or off the solver. And as we work through this tutorial, we're going to have multiple iterations of this. So we want to make sure that we only have, and it can be intensive computationally. So we want to turn off the solvers that we're not using and only turn them on when we need them. So then the last component I want to add is iterations. And I have to admit, I'm pretty excited about learning this new shortcut. And that is, if you want to create a panel, you can do // This convention comes from commenting code in that it wouldn't be normally read. And so it does make sense that we could comment something by adding a panel. And so if we do, and it's nice, it's on the top of the keyboard, or at least for me, the number pad on my keyboard. So // and then 50 enter gives us a nice little panel that has 50. And we're going to set that to iterations. I'm going to use that shortcut for panels from here on out, just // and then type whatever you want to initiate the panel. So now these are basically everything that we need for our output. We can also add a geometry output. And so we can have that. Obviously, there's nothing there yet, and that's okay. So we have this curve sitting off to the side. Let's do a couple of things with it. Let's start with capturing its endpoints. And we have those. And so with the kangaroo2, we're going to kind of consistently do 3 things as a way to give it the information that it needs. The first thing that we want to do is give it constraints because we're also going to apply a force. And so between those 2 things, as we apply a force, we have to constrain the model so that it doesn't just fly away. And so we'll add forces, we'll add constraints to fix the model. And then the third thing that we'll do is we will explain to the model how to work with its lengths or with its springs. And because what it's doing is it's using the length and it's allowing the model to stretch and distort. And so we can do each of those 3 items in a couple of different ways, and we will use a couple of variations throughout the course of this tutorial. So let's go up to kangaroo2, and there's goals. With goals, we want to grab an anchor. And we can place the anchor. While we're also in goals, we can grab a load. We want to put a load on different aspects in order to simulate it. And then in this instance, we're also going to get goals and use length of a line. And so given these, the anchor, the load, and the length, we'll use these as a way to feed them to the solver. And we'll start to see what happens. This is going to should be quite interactive. So let's start with our anchor. And let's give the start point, create a point container for our start point, and we'll feed that to our anchor point. And let's see, the strength is set to 10,000, and that's fine because we really don't want the anchor point to move. We want to keep it in that location. And so we can feed the anchor into the merge. And now the next thing is the loads. So we'll create another point container, and we'll feed the endpoint to this. And let's put that point into our load. So basically, we have this simple line. We're fixing one of the points, and we're loading the other point. So what do you expect to happen when we do this? So let's take a look at it. Let's look at how we load that point. We're going to take a force vector. So we could say Z in this case because Z is vertical. And I'll plug that in for the force vector. And for the force, let's say, I'm going to intentionally do this incorrectly, but we're going to create a panel. So // and let's say 1. This is positive, meaning that the force will be going up instead of down, which we would expect. But now let's plug the load into the merge. And we can even, let's see if anything happens. So let's double click false, and then we'll hit reset. So nothing's happening yet, but that's okay because we still have to explain to it how to deal with the length. And so let's plug in the line into the line. Couldn't be easier than that. Then we'll plug the spring into D4. So something's happened on the right-hand side. Let's take a look and see. So if we click our button, this will reset it, and we can see what happens. So we're applying a force to the point on the right, and it's fixed at this point on the left. And so what it did is it swung up and then it bounced a little bit. So have some fun and hit the reset button a couple of times. Now let's look at changing a couple things. First, let's change our vector to -1 because we want to develop this as an analog to Gaudy's hanging chain model. So now as we hit the reset, we see that that drops. So it's under a certain amount of weight. So now let's also set the length of our line. And we'll do that with the length component. And if you've installed kangaroo2, there are a couple of other length elements that show up here, but we want to measure the length of a curve. So we'll take our curve and we'll plug our length into length. And then we have to set our strength. Let's do this with a small panel, //. Let's set it as 100. We'll see how this works. Click reset. Okay, that seems to be working nicely. The one thing that I would like to do is let's see. Let's compare something now, just as a way to explain how this model's working. So let's create a panel. I'm going to plug in the length of the line. So we can see that our line is just over 100 units long. I think I may be working in inches. Let's create a panel and see what's coming out of the geometry. So there's a null, and a line. And we can see that the line is a little bit longer. So I'm just going to do one thing first, and let's create a list item. And we know that we want the second item from that list. And so then we have that. Let's slide this down next to so we have our starting length, 100.45, and our finishing length, 100.46. So if we change the strength of our line of this constraint, let's set this to 10. We'll see what happens. We see that this dimension changed. Let's set this to 1. We see that that dropped even more because what we're doing is we're simply applying a downward force to this one point. We can even hit reset. And we can see the way that that's playing out. Let's set the strength to 0. Now it has no strength whatsoever to retain its length, and it just keeps getting longer and longer and longer and longer. So let's try 0.1. And so the starting length is 100. The finished length is 110. So now that's the kind of string-based or spring-based aspect to the simulation. Because what we've done is we've simply locked one point in its location. We've applied a force to a second point, and we can see where it resolves and how it plays out. And it's also, we're allowing the simulation to stretch this line. So that's really, really simple. Let's copy all of this, and we'll make a couple changes. Because what I want to do is create a really simple two-dimensional catenary hanging chain model like we saw with Gaudi. So before we do anything, let's click the Boolean toggle in the upper portion to false. Let's click our lower one to false as well as we develop it. What I'm going to do is I'm going to unhide my lines, copy it, although we could just simply draw another line. But at least now we know that the starting length is the same. And let's reset our first curve, our curve container, to our second line over here. We can unclick this and reset it, and now we see that that one is also hanging. But let's change a couple things, or let's add a couple of things. So first thing, well, I'm going to delete these two panels. I want to create it more like a catenary structure. So the way that I'm going to do that is to divide our curve. It'll default to 10, and maybe that's okay for now. Now we can see 10, it's been divided into 10 points. What I want to do now is take that first line and I want to split it or break it up at each of those points. And the command that we use for that is shatter. It took me a while to find that because I don't believe shatter is a command in Rhino, but it is a command in Grasshopper. So we want to shatter our curve. So we'll pull our curve in, and then we're going to take the parameters from the divide curve and plug it into the parameters of the shatter. So that's good. Now let's take so we have our anchor points. Let's add our end point. See, we have our start point and our end point. Let's add our end point holding down Shift to the anchor because we want the two endpoints held and we want to let this cable drape. And from the load, let's disable or disconnect that point from those loads. Let's create a new point container. We can plug this in to the loads. And what we want to use this time is the points from our divide curve. We want to load each of those points to that. And now let's take our segments, our individual, right? We've got, what did it say? 10 locally defined values. Let's plug those into the curve or into the curve length. So we have that. And let's plug our shattered elements also into the line. I think that's right. And let's hit reset and see what happens. We have a hanging chain model. And what I want to draw your attention to is we can hide a number of things here. Let's see what's coming out of our geometry now. There's a number of nulls and a number of lines. So our list item doesn't make much sense now. We're not trying to grab just one item, so we can get rid of that. And we can look at cleaning up the nulls later. Well, let's do that now. It's an easy command. It's called clean tree. And what we'll do is we'll take geometry, plug it into the tree, and plug the tree into here. And we see that what the clean tree does is it just removes any null values, any empty values. So now we have these dimensions. We don't need to compare them because we can see visually what's happening. But let's look at the way that that changes. And this is a really nice demonstration of what I would kind of call tributary area or tributary loading, because each one of these points has a load applied to it. So this means, and what we see happening successively is that this cable, this element, is stretching more because it has the load of 1, 2, 3, 4, 5 loads pulling down on it. So that one stretches more. This only has 1, 2, 3, 4 pulling it down, then 2, then 1, and then just the 1 at the end. And so what we see is each of those lengths is stretched successively more along its length because of the way that it's loaded. We could change the count. So we know it starts with 10. So maybe set a slider to be 20. And we can see it's a little funky, and that's because it's just simply solving. What we want to do is hit the reset button, and that should fix that. And remember, we've just added a lot more load to the same geometry. So if we want to change the strength of the line length, let's set it to 1 now. That just got a lot shorter. And so remember, we're not putting in actual loads, we're not putting in material properties. And so this isn't a finite element analysis for structural engineering. It's just for form finding. Or I don't want to say just for form finding, because I think form finding is really useful and necessary at points. And so we end up with a really nice curve. And depending on the length or depending on the load, we can get this shape to vary. Let's try 0.6. So we see a nice distribution between the length at the top and then the way these get successively shorter as it comes through there. And so this should give you a sense. We're going to do this consistently now with using our Bouncy Solver, an anchor, some type of loading, and then a line length. And so what I'd like you to do for your first submission is to just send me a simple animation where you're changing the number of divisions, the strength of the spring, and maybe the load applied. And so as you work between those, we'll see the way that these change. So that'll be your first submission. So what we should see is just the simple 1 point hanging chain, and then the distributed loads on a hanging chain for that. So that'll be your first submission. But again, we're going to use this same model, and we can even copy this we'll copy it once. Let's copy it down. We'll use it as the model for starting to work within the courtyard. We do want to turn the Boolean toggle to false for all of the previous examples. And as we look down here, we're going to make some changes to this, but let's do this. Let's get rid of all of these elements so that we just retain our length, our load, our anchor, and our show. And we can toggle that off, and we can keep all of these here. And so this will be a useful grouping for our next couple of steps as we start on the courtyard canopy. Here's a good place to stop. Let me know if you have any questions. I hope this helps you understand the basic concepts for the kangaroo2 plugin and thinking about relaxation, surface relaxation. We're going to start working with meshes now, but let's pause, and then we'll get started with the second part. Thanks.